So an amine, this is a hydrocarbon derivative where you have a nitrogen bonded to a carbon. So you can have a primary amine, and that's when there's only one carbon bonded to the nitrogen. The other two bonds are hydrogens. In a secondary amine, the nitrogen is bonded to two carbon chains, one hydrogen, and then we have a tertiary. It's bonded to three different carbon chains. So whichever type of amine you have, the longest carbon chain becomes the parent, becomes the root. So whether it's bonded to one carbon or more than one, find the longest carbon chain, and this becomes the parent. So longest carbon chain is the parent or the root. So what you have to do is, for your suffix, you drop the E off of the alkane and you add a number telling you which carbon the nitrogen is attached to, and the word amine. So which carbon is it attached to in that longest carbon chain, followed by amine. If you have a primary amine, you're finished. If you have another carbon chain, that carbon chain becomes an alkyl group, and we list them alphabetically. So the other carbon chains, if they are there, if it's secondary or tertiary, you're going to count the carbon chains, name them as alkyl groups, but you're going to put a capital N in front. So if it's if you have a 3-carbon chain that's a side group, becomes N-propyl for 3 carbons. And if it's a tertiary, you name them alphabetically. So let's name these two structures. So let's take a look at this first one. We've got an amine. It's primary amine because there's only one carbon chain. And it's 2 carbons in length. So in this case, we don't need a number because either carbon would be carbon 1. If it had 3 carbons, it could be attached to carbon 1 or carbon 2. So we would need a number. So this is ethane. Take off the E and add amine. So this is ethanamine. The second compound here has 2 carbon chains. And 1 hydrogen. So this is a secondary amine. The longest carbon chain is 3, so it's a propylamine. Because it's attached a carbon at the end carbon, it's attached to carbon number 1. If it was attached to the middle carbon here, it would be 2 amine. So we've got a propane, and it's attached to carbon number 1. So it's propan 1 amine. The other carbon group has 2 carbons in it, so it is N-ethyl. So it's telling us there's an ethyl group on the nitrogen, and it's N-ethylpropan 1-amine. Okay, so identify the root. Identify the root, draw the carbon chain, and number it. Add the nitrogen as indicated by the suffix. So it'll give you the number. If there is a prefix on this portion or on the root, add the side group. Then add any other carbon chains as indicated by the prefixes with the N in front. Okay, let's draw this structure. N-ethyl pentane 3-amine. So this is telling us, there's the root, because it comes before the number and the word amine. So it's 5 carbons long. And the nitrogen is attached at carbon number 3. Attached to this N group is also an ethyl group, which means it also has an H, because there's no other N prefix. So this has an ethyl group attached. Now go back and put in your hydrogens. To make this neater, you could also bend your side group. Sorry, bend your main chain. If it's not attached at carbon number 1. So if you plug in all your H's, there's your structure. Primary and secondary amines have a nitrogen with an H bond. As you know, this is very polar, and it is capable of forming hydrogen bonds. So you have, for intermolecular forces, here London dispersion, dipole-dipole, and hydrogen bonding. As a result, it will have, they will have rather, a higher boiling point than alkanes with the same number of carbons, or tertiary amines. Because nitrogen has a lone pair of electrons, it can accept hydrogen bonds from water. So, both primary, secondary Amines are highly soluble. Tertiary is less soluble because it can't form hydrogen bonds with water. It can only accept. So amines are quite soluble in water. Again, the longer the carbon chain, the less soluble they become.